I'm going to speak today about is a very new part for us. It's an impeller for a centrifugal compressor. Impellers today made from metals are of two different types. They are either open, as you can see on the upper right side. An open impeller can spin at a maximum tip speed. The tip speed is the tangential speed at the surface, at the external surface, of about 500 meters per second. And a closed impeller, which is a preferred method typically to compress light gases and has other advantages over the open impeller. But a closed impeller, because of the added mass on the external surface, is also limited to lower speeds. Tip speeds of 360 meters per second in service is about the maximum you can see. And we, as I said, are working with composites, thermoplastic composites, which are typically much lighter than metals and still have a very high strength and stiffness. So what we're looking at is the ratio between the strength and the mass, and that's called the specific strength and specific stiffness. And composites have a fantastic advantage over metal. So theoretically, if you can make an impeller from composites, you could make it in such a way that it could spin significantly faster. And I will explain later why the faster spinning is something that we're looking for. So, of course, as I said, on paper, this works, but to do it in practice is another story. And hence our initiative within Greene Tweed to produce this as a demonstrator to show our customers that we can do that. The compressors that are used today to compress hydrogen are reciprocating compressors. Reciprocating compressors, as you can see on the left, have a piston that compresses the gas, and with that, any gas can be compressed. But the limitation is the amount of gas you can compress in 1 second. So in this case, you can see that with the largest units of reciprocating compressors, 8 cubic meter can be compressed in 1 second. Now that sounds like a lot, but 8 cubic meter of gas, of hydrogen, is 600 grams. And 600 grams per second is still a very small quantity of energy. Even if hydrogen has about 3 times the energy of standard gasoline, you still can't feed a city with energy if you can only transport that amount of gas. So with a centrifugal compressor, much vaster volumes, here 25 times more, can be compressed, and this is exactly the kind of technology that's needed to enable a hydrogen network. I will now come to the explanation of why the faster spinning. So the way a centrifugal compressor works is that you can see on the upper left-hand side, the gas comes in, and then the wheel, or the impeller, spins very fast to accelerate the molecule. The molecule in this 2D view is pushed up and comes back down. Of course, this is over the whole circumference, but just schematically here, it goes up and comes back down and goes into the next stage. Now you can see the next stage is a little bit thinner because the gas is now a bit more compressed. And then again, the molecule accelerated, pushed into the next stage through centrifugal forces. Now, if your gas is lighter, you can even intuitively understand why this molecule will have a harder time to be accelerated by spinning a wheel. And in fact, the proportionality between the mass of the gas and the speed that is required for a certain compression ratio is given by the equation here, the mass times the tip speed square. And that means that, for example, if you are compressing methane, which is 8 times heavier than hydrogen, you can do that with a certain speed, tip speed. To get to the same compression ratio with hydrogen, you would have to have a tip speed square root of 8, so 2.8 times faster. And that obviously is not possible with metals. Closed impellers like this are about at the failure level at 440, 450 meters per second. It will explode, typically into 4 pieces. And that's still far too slow to compress hydrogen. For hydrogen compression, a tip speed around 600 meters per second is required. As I said at the beginning, thermoplastic composites have a great advantage because of their low weight and high strength. So they have a very high strength to weight ratio. We're typically, if you compare ourselves to steels or Inconel, we're about 5 times lighter, and the strength is obviously not 5 times lower. In fact, in the fiber direction, it's even higher than metals. And to make an impeller, you have to orient the fibers in a number of orientations. But overall, there's still a great advantage to be expected. At this stage, a few years back, this was still just on paper.